Welcome back to Monroe Live, everybody. Today we're going to talk about the Giga castings. So on Friday, if you were following us on Twitter or Instagram, we got these things removed relatively quickly, and Jordan's going to run through the process to get them out, and then we're going to go into a lot of features about them. So Jordan, how'd it go getting them out?
Yeah, it was a heavy lift for the guys actually getting it out. So we used a few different things. We started out plasma cutting, so anywhere there was an SPR or a bolt that we couldn't get with a power tool just because they actually use structural adhesive in the threads in some cases, we're using plasma cutters. Then the next layer is all the structural adhesive. So if you look on the sides of these castings, you're seeing all this purple goop. So that's structural adhesive. So that stuff is so powerful that in many cases, the bolts are just to get the body structure fixtured, and then the structural adhesive is what does a lot of the actual adhesion and connection between the components. So,
and Jordan, is this one of the bolts that was cut off?
Yeah, so those were very interesting in that those specific bolts, so this is the lower inboard corner at like the bottom of the hinge pillar, so just next to the front passenger's right foot, essentially. Those bolts are the thing that absolutely confirmed for us the build process. So it confirmed that the first order of operations of this whole body structure going together is these castings going in the line. Then they've got an inner assembly, so the inner panel, like the big body structure that you could probably see behind us later in the video, that comes in next, and that was confirmed for us by these bolts because they are not visible nor accessible when the full body structure is assembled and built. So those are a in-process bolt hidden within the section, and then lastly the body side outer, or like the A surface, what you see as the customer, comes on the side and is bolted in. So getting those out was the last thing on both of the castings that we had to free up.
Yeah. And these castings are beautiful examples of integration. So many pieces and parts are integrated. I know Tesla showed, 172 parts were eliminated and replaced with just two 1600 spot welds. And focus on some of the pieces that are integrated. So this is the mount for the front motor. Is that right, Jordan?
Yep.
Some pieces they were not able to integrate. I know we covered this in an earlier video with Carl and I, and there is some spot welds here. So I know we couldn't see it in our other video, but you can see 1, 2, 3, 4, 5 spot welds, but also the purple structural adhesive as well as behind that. So a lot of people really want to know, what does it weigh? So as you see this thing sitting on the floor right here, it's 187.4 pounds. Is that right, Jordan?
Correct. Yep.
187.4 pounds. That does have some small brackets and pieces connected, particularly the crush can, which is bolted on, and this fender support, which is bolted on. There are a few pieces which are welded on, and then there's another piece, there's a steel reinforcement that's secured onto the underside of the shock tower, and Jordan can talk a little bit more about how that's secured.
Yeah, so this was really interesting in terms of the fastener utilization here. So they've got fasteners running from the underside through to the upper side, and if you look really closely, at first I glanced over it when we were first getting this exposed, but it's a threaded fastener that's actually acting like a rivet. So the tube, or that little collar around the fastener, before the fastener is installed, that's probably a straight walled tube, and then as you run the fastener down, it's sucking the sidewall of this in, so what you get is like a pop rivet effect, but they're doing it with a threaded fastener. So kind of an interesting application there. I'm sure it's holding just fine, but those brackets, those are new for the 2022 model year, or any vehicle that's equipped with a Giga casting. And the other thing that I found unique here is they actually changed the bill of process. So the sequence in which the vehicle comes together.
Now, correct me if I'm wrong, Jordan. The old Model 3 and Model Y did have an aluminum bracket that bolted up to the shock tower. That is gone now, because I'm looking at this is the front right here.
Correct.
And so they're just using these 3 points here. That big aluminum bracket is gone, but that interfaces with that steel doubler and the portion of the shock tower.
Correct. In the cast aluminum portion, what was unique about it in the previous iterations is it allowed the upper control arm to be part of this assembly before it came to the vehicle, because then everything could be fastened vertically as the whole assembly came in.
And now the upper control arm is secured through these fasteners right here.
Correct.
Yeah.
Correct.
So what we're going to do is we're actually going to remove this front piece right here, because I want to see what it looks like off. And let me see. What is it? What do you think, Jordan? 13?
Probably 13, yeah.
It's like structural adhesive done. Oh, they did spot weld it.
Spot welded it, yep.
Look at that. So not only was this secured with fasteners, it looks like you have one really good spot weld there and a spot weld there. Now I was able to just kick it off.
Yeah, I would submit that if this were structural adhesive, he probably would not have been able to kick that off. That's how strong that stuff was holding throughout the other components in the body.
This was also put on before they sent it through E-coat.
Correct.
You can see the contact patch there. It's a really interesting piece here. And we could probably pull this out. What size is this? Probably 13?
Yeah, the only hard part here is they actually, when we were talking about putting structural adhesive in the threads, they put structural adhesive in these bolts, so those might really be locked in place.
Now let's move on to the rear, Jordan. So this is much improved from the rear Giga casting that we had in our early 2020 Model Y, because it did not include the rear crush cans or that crosscar piece right there. Ours was also split down the center, and it had a cover. So a huge amount of integration here that's improved quite a lot in the past 2 years. And Jordan, you want to talk about how it was getting this out? A little more difficult.
Yeah, this one was definitely more difficult because there was a lot more geometry and different planes that we had to sort of hurdle over in the rear area as it came up the rear shock tower along that C-pillar transition. It really sort of locked the thing in place. So we actually took a hydraulic jack at the base of the sill section, so on the stamp body in white, to spread it apart to give this some space to breathe so that we could sort of jimmy this thing out. So this took 3 or 4 people multiple hours to try and work through and get this out.
The rear corner of the car sleeved over this, but there was so little structure cross car that we were actually able to like bend the rear corner of the car out to get it to move.
Right. Yeah, and obviously that wouldn't have been possible if we had not taken the bumper beams off, right? So there is structure when the vehicle's fully assembled, but after you take that off, like Corey mentioned, those just kind of bend out of the way.
Yeah, the 2 threaded fasteners we really struggled to get access to were the ones that came through the lower rocker, right, Jordan, and secured into the side of the casting. We ended up using a Sawzall and cutting down right here. This was in between the body side inner and the casting so that we could make it all the way to where that bolt was, cut the bolt off on the left and right side. That was the last frontier for getting this thing out. Once we got those 2 bolts cut, the bottom was able to spread and the casting was able to be, pulled out pretty easily.
Right. And you can see some chunks sort of peeled off of the casting here in a lot of the corners and a lot of these flanges. When we talk about aluminum being brittle relative to a more ductile material like stamped steel, that's what we're talking about. So it doesn't bend very much or deflect very much before it'll actually snap off. Now it's extremely rigid, but that's one of the drawbacks, especially when it comes to impact.
Now, one of the biggest questions we get on Monroe Live is how can you service these, or you'll never be able to service them. So in the rear, if you take a large impact in the rear and you're smashing far up into the left rear or right rear corner, the vehicle is most likely going to be totaled. Front, you can take a little bit more of an impact and there's crush cans and sacrificial pieces to repair. And if you look at a traditional stamped steel body, if you're getting in a bad enough accident where you're messing up the rear shock tower, or you have cross-car geometry issues, or your front shock tower, or you've torqued the engine bay if you have an engine, the car is going to be totaled. So repairability for the rear, like if someone were to say, oh, I got to replace the whole casting, I don't think it's going to happen. Absolutely not.
Definitely
Even
not.
we got it out, but at the detriment of destroying the body. So we'll go check out some of the damage we did to the steel. Our team pried pretty heavily. We also plasma blasted the holes out. There is a method of using a drill, but it's very time consuming. You burn through a lot of bits, and it's just easier if you just use the plasma cutter. And at certain points, we actually heated it up to melt some of the structural adhesive, and I think it worked pretty well. Here's the location of that last bolt. It's right here, Jordan. There was one here.
Correct.
And yeah, I think it was here. No.
It was up higher. It was, yep.
There.
This whole area, when Corey was talking about torching it, we had this thing fully tensioned out with the hydraulic press. So there was a tube going from the inside of the sill to the other inside of the sill. So we had hydraulic press fully tensioned out here. And then not until concurrently when we hit it with the torch did the thing pop. So we had as much pressure as the hydraulic press could put out on these sills. It didn't budge. Only when we hit this whole area with a hot torch did it denature the adhesive enough to the point where it physically popped away from the side of the sill.
And the front, let's see. What was this part for, Jordan? This small piece. Is this a separator, or what is that?
Yeah, nearest we can tell right now, until we've looked at it further, it seems to be just a reinforcement for that corner, right? So from a small overlap rigid barrier impact perspective, we talk about that quite a bit on the channel. So it's 25% of the width of the vehicle. A lot of the energy and the load coming into the vehicle comes directly to this hinge pillar. Right, so this is one of the primary items it's going to hit. And so what this may be is additional reinforcement so that this sheet metal did not tear, and or because there were fasteners all throughout the inside of this, so that the fasteners didn't start to tear through the sheet metal during impact. So it's probably helping maintain some structural integrity as far as the joint is concerned there. And you can see, you know, the fore-aft length on this is pretty substantial, right? A lot of vehicles have much smaller hinge pillars, but you know, that's one drawback with an EV, that when they get heavy, you need to have structural countermeasures to manage the energy.
It's also amazing to see how few parts are left in the body structure when you remove the front and rear casting. You see the body side outer, the body side inner are two major components. These have now become larger parts. Our initial Model 3 was much smaller. You can see they're still utilizing tailor welded blanks right here. So they'll typically vary either the thickness of the steel or the quality of the steel. So they go from ultra high strength steel to very high strength steel, boron steels, hot stamp steels. And this is the separating line before the part is ever formed. The blank has different thicknesses, just like we saw on the cover of the pack for the battery. I think we had 3 or 4 different thicknesses. The leading edge of the cover of the pack for the 4680 was thicker. There was a thin section. It was thick over the seats, and it was thin for the rear. So an interesting use of materials here on the body, but so few parts. I mean, imagine working in this body shop, Jordan. I know we have 3 or 4 people at Monroe. We have Scott Hildreth, who's worked in body shops for years, and we have Paul Lester, who worked in body shops for years. They were both blown away by how few parts are truly left. And
well, and the thing to me, in addition to just the part reduction, is the way that they accommodate net build versus slip. So what I'm talking about there is, you know, there's a lot of stack up and tolerances if you've dealt with GD&T at all. So as all these panels come together, there's only a certain tolerance that you can hold key dimensional artifacts on the body in place with, you know, vehicle after vehicle after vehicle. So on the new Model Y, they actually lock in the width of the vehicle via the casting. So when the casting drops in, there is no cross-car adjustability. It is a net lock in here. And then what they do on the greenhouse, or this front header, the greenhouse is what we refer to the upper body structure as. You see this stamping like goes inside, right? There's like a channel for it, goes inside this intermediate bracket. And what that allows them to do is actually vary the position of it ever so slightly cross car, or in the y-axis for those of you who are running CAD. So they still have some cross car adjustability at the top, right, for the tumble home and making sure that all of these features are aligned, but the bottom is locked in by the castings. There is no adjustability down there.
Very cool. All right, anything else, Jordan?
No, I think that pretty much covers it. I'm really looking forward to getting a net mass when we get all the brackets and things off of the front.
We never said the mass of the rear. What was the rear?
66.5 kilograms, so that's just over 145 pounds.
145 pounds. And then any acronyms we missed? You said GD&T. What's GD&T?
Geometric dimensioning and tolerancing. So it is the practice of making sure that you've got alignments, it's evaluating stack ups, it's looking at PLPs, so primary locating points, pins, so it's how they index the entire vehicle, among other things.
Yeah, and to wrap things up, I just want to remind all our viewers, we are not YouTube engineers. We're an engineering firm first. We have nearly 100 employees at Monroe & Associates, some of the top experts in their field, battery experts, electronic experts, body and white experts. So a lot of the information that we're disseminating in these videos is collaborated with our team of experts. So if you're out there wondering like, man, you know, where does Monroe & Associates, you know, get all this confidence behind the stuff we're saying? And really it's the confidence of our entire extended team. So we want to thank everybody for watching. We hope you get some value out of the stuff that we cover. Jordan, thank you as always. I think you're like our #2 or #3 Monroe Live contributor. Jordan just joined Twitter. He wants some followers, so go find him on Twitter. I think we want to get him over 1,000 followers, so that'd be kind of nice. And that's about all I have. So thanks and have a nice day.